Good afternoon. Today we're going to do lesson 5.2, solving inequalities by multiplication and division. There are a few basic facts. If we are multiplying or dividing both sides of a true inequality by a positive number, so by a positive number, it will remain true. Okay. However, if we multiply or divide both sides of a true inequality by a negative number, we have to do something a little different. So if we're multiplying by a negative number, the direction of the sign must be reversed. Okay, so the direction of the inequality sign must be reversed for it to remain true. Okay. So basically, we can draw a little table to kind of help us remember this. If we know that we are multiplying or dividing, it doesn't matter, by a positive value. Okay. So a positive value and we multiply or divide, the inequality remains true without doing anything. Now, if we multiply or divide by a negative value, then you must reverse inequality sign. So reverse inequality sign to remain true. So this will be very helpful moving forward when we're solving inequalities, especially when we get to multi-step inequalities. Okay, so let's start out by looking at example 1. So in example 1, we are going to solve 1/8 n is less than 84. So to solve this, we can multiply both sides by the denominator 8. So I multiply both sides by 8. And that will cancel out my denominator and leave me with n is less than 672. Now, I know from previous lesson that I have to write my solution as it is in set builder notation. So the set of all numbers n such that n is less than 672. And close my brackets or teacher squiggles there. Now let's check our work, and we're only going to do 2 checks. So we're going to pick a number that is greater and one that is less. So in our case, if we pick a number that is less than 672, it should be true. So let's try that out. So if I pick, let's say we pick 2 to be n, so n equals 2. If I plug that in, I should have 1/8 times 2 should be less than 84. And 1/8 times 2 is in fact 1/4, and that is less than 84, so it's true. Okay, what if I pick a number that is larger than 672? According to our answer, it should not be true, and we should get a false. So let's try n as 720. So if I do 1/8 times 720 should be less than 84. Now 1/8 times 720 gives me 90, and 90 is in fact not less than 84, so that is false. Okay. Now let's move on and look at example 2. In example 2, we have to solve for -2 is greater than or equal to negative d divided by 34. Here, we are going to multiply by our denominator again, the -34. So when I multiply both sides by -34, we have to refer back to our rule that I said earlier. If we multiply by a negative value, we must reverse the sign. Okay, so we have to reverse our inequality sign. So let's do that on this next step here. So -34 times -2 gives me 68. Now I have to change that sign because I multiplied by a negative. So now it becomes less than or equal to, and I have -34 times negative d over 34, which cancel out the numerator, the denominator there, and just gives me the value d. So let's write our answer in set notation. So we have this set of all numbers d such that d is greater than or equal to 68. Remember, when we have it written as 68 less than or equal to d, in set notation, we have to have the variable come first, so you must switch that. Now let's do our check and see if we are in fact correct. So let's choose a number that is less than 68. So let's try d is equal to 17. When I do that, I have -2 is greater than or equal to -17 divided by 34. All right, -17 divided by 34 gives me 1/2, positive 1/2, and positive 1/2 is not less than -2, so that is false. All right, so that checks out. Now let's try one that is larger than 68. So d is equal to 102. So I'll have -2 is greater than or equal to -102 divided by 34. And I'll have -2 is greater than or equal to -3. In this case, -2 is greater than -3, so that is true. All right, now let's move on and look at example 3. In example 3, we have to solve for -3 divided by 7 times x is less than 21. So here we're going to divide both sides by our fraction -3/7. Okay, and remember, if we're dividing by a negative, we must reverse our sign. So when we divide over here, we're canceling those two out and we're left with x. Now we have to change the sign, so we must reverse that. So instead of less than, it's going to be greater than, and 21 divided by -3/7 gives us -49. Now we have to write that in our set builder notation. So we have our brackets. So a set of all numbers x such that x is greater than -49. And close our brackets. Let's check our work to make sure we are good. So if we check it, let's choose a number that is higher and lower. Let's try x as -50. So if x is -50, I have -3/7 times negative 50 should be less than 21. All right, negative 3/7 times negative 50 gives me 21 and 3/7 is less than 21. Well, 21 is equal to 21, but then I have 3/7 more, so that is false. That would be larger than 21. So that does not satisfy our inequality. Well, let's check one that is, in fact, greater than negative 49. How about x can be negative 42? So if we check it at negative 42, I'll have negative 3/7 times negative 42 should be less than 21. Negative 3/7 times negative 42 gives me a positive 18, and 18 is in fact less than 21. So that is true. So you can see how in these last two problems, we had to reverse our inequality symbol to make it remain true in our final answer. Okay. All right, let's look at our last example for today. We have example 4. 1/5 m is greater than or equal to negative 3. So here we're going to divide both sides by our fraction 1/5. And notice it is a positive number that I'm dividing by, so I do not need to change my sign. 1/5 divided by 1/5 is 1, so I'm just left with m is greater than or equal to negative 3 divided by 1/5 gives me negative 15. And I write it in set notation. So I have a set of all numbers m such that m is greater than or equal to negative 15. And close my set. Let's check our work with a number that is higher and a number that is lower. So let's check it at m is negative 20. All right, so I have 1/5 times negative 20 is greater than or equal to negative 3. Well, 1/5 times negative 20 gives me a negative 4. And negative 4 is not greater than negative 3. It's smaller. We're going the other way on the number line, so that is false. Okay, let's try a number that should meet our inequalities requirements and be greater than negative 15. So let's try m to be a positive 5. So I have 1/5 times 5 should be greater than or equal to negative 3. Well, 1/5 times 5 gives me positive 1, and positive 1 is greater than negative 3. So that is true. All right, on here, notice that we did not have a negative sign that we divided by. We had a negative 3 right here, but we didn't actually divide or multiply it. So as long as you are not multiplying or dividing the number that is negative, then you do not have to change the inequality sign, only if it is what you are dividing into another number or multiplying into another number. Like example 3, we were dividing by negative 3/7. Okay. All right, so you have some problems today as well. There are 4 for you to practice on your own. You need to have these ready to go tomorrow morning as you are working on your bell ringer. Have a great day.